It's another time with BakoMaths, and to this lesson we'll be looking at the multiplication of complex numbers. And if you haven't subscribed to this channel, kindly subscribe and hit on the notification bell so that when we release a new video, you are going to be the first person to be notified. Now let's get started. So you are looking at the multiplication of complex numbers. So you are saying that if you have the complex number a plus bi being multiplied by another complex number of the form c plus di, then what you are saying is that we are going to follow the normal procedure of multiplication. So it means that a multiplies the whole of the bracket c plus di, so that is a multiplied by c plus di, and then our bi also multiplies c plus di. So at this point, we can see that a times c gives us ac, and a times di gives us adi. Then move to the other parts. So bic gives us bci, and then here we have bdi squared. So once we have this, then what we have to note in complex numbers is that whenever there is I squared, then it's equal to -1. That is, for every I squared, its value here is -1. So you are going to substitute in that. So here we have AC plus ADI plus BCI plus BD. Here we have I squared here, which means that we are going to substitute -1 there, which means we have AC here plus ADI there plus BCI and then minus BD. So here we can group them, which means the real part goes to one side, that is AC, and then we have minus BD. So put it into a nice parenthesis, plus, then the imaginary part here also becomes ADI plus BCI. So into one parenthesis, of which we can factorize the I out, plus AD plus BC or I. So this is what we have. So this is to communicate to us that whenever we have two complex numbers multiplying, then when we follow this procedure, our final answer must be of this form. Now, once we have the idea of multiplying two complex numbers, then let's take practical examples on instances like that. So example 1, it says that given z1 to be equal to 3 plus 2i and z2 to be equal to 4 plus 5i, find z1 times z2. So that's the application part of the multiplication of complex numbers. So you have the complex number z1, complex number z2. You want to find z1 being multiplied to z2. So once we have this, then we know z1 is the same thing as 3 plus 2i, and then we also know that z2 is the same thing as 4 plus 5i. Now once we have this, then we multiply using the normal procedure, which means 3 multiplies the parenthesis 4 plus 5i, and then 2i also takes that of 4 plus 5i. So at this point, you can see that 3 times 4 gives us 12, and 3 times 5 gives us 15i, plus here we can see that 8 times 2 gives us 82i, and then plus 5 times 2 gives us 10. I times I gives us I squared, so that is 10i squared. You have to remember that for every I squared, its value here is -1. So we do the substitution here. So 12, and we can see 15i plus 8i gives us 23i. So plus 23i. And then here we can see that you're going to have plus of 10 multiplied by minus 1. Now once that is clear, then we can see that we have 12 minus 10 plus 23i. So at this point, you can see that 12 minus 10 is the same thing as 2, and we have our 23i here. So it means that the multiplication of z1 and then that of z2 gives us 2 plus 23i. Now let's move to the next example. So we have example 2 as such. It says that given z3 to be equal to 4 minus I and z4 to be 2 minus 3i, we should find z3 dot z4. I think at this point you can pause the video and try your hands on this. All right, so we continue with our solution here, and we want to find z3 dot of z4. So which means we have 4 minus I multiplied by 2 minus 3i. Here we can see that 4 will multiply 2 minus 3i. We can also see that minus I will also multiply 2 minus 3i, which means 4 times 2 gives us 8, and 4 times 3i gives us 12i. Here we can see that I times 2 gives us 2i, and minus I times minus 3i gives us the positive of 3i squared. Now once that is clear, we know that for every I squared, its value here is minus 1. So once we know it, then we substitute as such, which means we have 8 here minus, so minus 12i minus 2i gives us minus of 14i, and here we have 3. Now this 3 multiplies minus 1, of which we can see that we have 8 minus 3 minus 14i, which gives us, so 8 minus 3 gives us 5, and we have our minus 14i beautifully as this. So this is how we solve z3 by z4. Now we'll move to our next example in this video. So we have example 3 here. It says that if z1 is equal to 1 minus 2i and z2 is equal to minus square root of negative 4, find z1 dot z2. I know someone is confused about we finding the product of z1 and z2, whilst we know that z2 contains the negative square roots of a number. It's very simple, and that is where complex number or complex numbers comes in. Now let's tackle this. So we are considering z1 and z2 being multiplied. So with the normal procedure, we know 1 minus 2i multiplied by 2 minus square root of negative 4. Now once we have this, then 1 multiplies 2 minus square root of negative 4 here. And we can also see that minus 2i also multiplies 2 minus square root of negative 4. Now once this is done, we can see that 1 times 2 gives us 2. And we can also see that 1 times negative square root of negative 4, definitely we are going to get square root of negative 4. Now we come here, negative 2i times 2 gives us negative of 4i. And here, negative 2i times negative square root of negative 4 gives us the positive of 2i square root of negative 4. Now we should be attentive here. Our next focus is to eliminate the square root of negative 4 so that we can get our answer straightforward. Now it means that we can simplify this by writing 2 minus square root of negative 1 Alright, so we have to write it well here. So 2 minus the square root of -1 times 4. And basically it's the same thing. When we multiply -1 and 4, we're going to get -4 all square root. So we write it as such, and you have -4i plus 2i. And the same thing also implies at this side. So -1 times 4. Now once we have this, we can also reduce it and say 2 minus square root of -1 times square root of 4 minus 4i plus 2i square root of -1 times square root of 4. Now this is where our I squared is equal to -1 comes in. Remember, we said that for every I squared, its value here is -1. So it means that when we take square root of both sides, then it means we're going to have I here to be equal to the square root of -1. So if that's the case, then wherever we see -1 in this expansion, then definitely we are going to put I there. So that is logic. And here we can see that 2 minus, now square root of -1 here, we know the same thing as I, so we bring our I here. And we also know that square root of 4 is the same thing as 2. So minus 4i and plus 2i. We also know that square root of -1 we know to be the same thing as I, so we bring it as such. And then we know square root of 4 is the same thing as 2, so we also write it. Here we can see that 2 minus 2i is there, and we have minus 4i plus, so 2i times I gives us 2i squared, and then also multiplied by 2. We are breaking it down one after the other, so which means that here we're going to have 2 minus 2i minus 4i plus 4i squared. So here we know it's equal to 2 minus 6i and then plus 4i squared. So we have it as such. And what can we see? We can also see that again, for every I squared is equal to -1. So for every I squared, we know it's equal to -1. So also do that substitution here, and we can see that 2 minus 6i plus 4 multiplied by -1. So here we can see that 2 minus 4 minus 6i. That is grouping like things strictly. And here we are going to have, so in something we are going to get -2 and then -6i. And this becomes the solution to our question. So example 4 happens to be the last set of examples for today's video. You can also pause the video and try your hands on this. Find z1 squared if z1 is equal to 1 minus 2i. So solution, z1 is 1 minus 2i, and you want to find z1 all squared. But z1 all squared will be the same thing as 1 minus 2i all squared. So with this 1 minus 2i squared, we know the same thing is 1 minus 2i multiplied by 1 minus 2i. So once we have this, then we multiply using the normal multiplication procedure. 1 multiplied 1 2i, and minus 2i also multiplies 1 minus 2i, which means that you have here as 1 minus 2i minus 2i plus 4i squared. So here you can see that we have minus, that is 1 minus 4i, and we can see that for every I squared, then we are going to get -1, which means 4 multiplied by -1. So at this point here, we can see that 1 minus 4 minus 4i. So which means 1 minus 4 gives us -3, and then we have -4i. And this becomes our solution to z1 all squared. So we end today's video, and thank you for watching. kindly like, comment, subscribe, and share. Remember that this is BakoMaths, thinking beyond infinity.